We looked at the blue scale in a previous lesson. It shows ram rise for any particular true airspeed. In this example, a true airspeed of 400 knots gives a ram rise of 17 degrees Celsius. However, when solving this problem with a temperature gauge that shows TAT, you need to know your ram rise to find the TAS. But you also need the TAS to find the ram rise. So how do we start? The way to do it is to start with the total air temperature, even though we know that it will give us a slightly wrong answer for the TAS. We then use this close but not quite accurate TAS to find a ram rise. We apply the ram rise to get a static air temperature, or SAT. We then find the TAS again, but this time using our new SAT. This time it should be correct. Let's get this clear, because it quite often causes confusion. The only reason we carry out the first calculation is to establish the static air temperature. After that, we discard it. It is the second calculation which finds the correct TAS. Let's take a worked example. The indicated air temperature, or total air temperature, is minus 28 degrees Celsius. We are at flight level 330. The CAS is 280 knots. What is the TAS? First, using the total air temperature, uncorrected for ram rise, find the approximate TAS. Set minus 28 against flight level 330 in the airspeed window. Now read off the approximate TAS on the outer scale against the CAS of 280 knots on the inner scale. What do you get? You should have 499 knots TAS. Now, although in step 1 we are calculating only an approximate TAS in order to find the ram rise, it is still worth getting it as accurate as we can. We therefore apply compressibility correction. Move the compressibility correction index 1.99 divisions, or more practically, 2 divisions to the left. What is the revised TAS? You should have found 479 knots. Now go back to the blue scale and set the cursor on 479 knots. What ram rise does this give us? You should have found an answer of 25 degrees. So if the TAT was minus 28 degrees Celsius, what is the SAT? The SAT is minus 53 degrees Celsius. We now have a static air temperature to enter with, so step 2 is simply finding TAS in the normal way and applying compressibility correction if required. Start by setting minus 53 degrees Celsius against flight level 330 in the airspeed window. Then find 280 knot CAS on the inner scale. What uncorrected TAS does this give you on the outer scale? This gives a TAS of 472 knots. Now we have to correct again for compressibility. 472 over 100 minus 3 comes to 1.72 divisions. Move the index 1.72 divisions to the left. And as before, read off the corrected TAS on the outer scale against the new position of 280 knot CAS on the inner scale. What corrected TAS do you get? You should have found a compressibility corrected TAS of 458 knots. We have now completed both Step 1 and Step 2, and found true airspeed, starting with total air temperature.